Within this video series, we're going to explore the integration of trig, and we're going to be essentially playing with powers of trig. So we will need three trig identities from pre-calc. That's the Pythagorean and the two half-angle identities that have just been a little bit modified for our purposes. If you need to write these down, they're definitely little notebook worthy. If you don't remember them, if you remember them, then you're good, but make sure you know your three identities. Within our first example, we're going to integrate with sine being an odd power and cosine being an even. I'm going to break sine cubed into sine squared times sine, and I am going to pull my singular sine of x to the back. Hopefully this will start to make sense as to why as we work through our example. Now we have sine squared of x times cosine to the fourth of x times sine x dx. We're going to use the Pythagorean identity that states that sine squared of x is equivalent to 1 minus cosine squared of x. And we'll distribute our cosine to the fourth. This is the integral of cosine to the fourth of x minus cosine to the sixth of x times sine of x dx. This sets us up for a very nice u substitution where u is equal to cosine of x and the derivative is equal to negative sine of x dx. And that's why I paired that sine of x dx in the clear back of our equation. We do need a negative to balance, and we're integrating u to the fourth minus u to the sixth du. And that's a negative of 1/5 u to the fifth minus 1/7 u to the seventh plus c. We should distribute and replace u with cosine. It's a negative 1/5 cosine to the fifth of x minus 1/7, actually plus, we're distributing a negative, cosine to the seventh of x plus c, and that is our expression for the integral. Now we're going to look at an odd power of cosine. It's going to be a very similar exercise where we're going to borrow a cosine and pair it to the back. That would leave us with cosine squared of x over the root of sine of x times the singular cosine of x dx. We use our identity and we turn cosine squared into 1 minus sine squared of x using our Pythagorean identity. We will break this up over the denominator, so it will be 1 over root sine x, or sine x to the negative 1/2 minus sine squared over the root of sine would be sine x to the 3/2 power. This is from pi over 6 to pi over 3 times cosine of x dx, and technically it is encased in a parenthesis because it's distributed to both. Our u sub would be sine of x. Our derivative of u would be cosine of x dx. So we don't need to adjust that piece. We should evaluate sine of x at our endpoints though. Sine of pi over 3 would be root 3 over 2. And sine of pi over 6 would be 1/2. Our integral will run from 1/2 to root 3 over 2 to u to the negative 1/2 minus u to the 3/2 du. At this point, we should integrate, and that gives us 2u to the 1/2 minus 2/5 u to the 5/2, longer interval 1/2 to root 3 over 2. At this point, I would use a calculator because we're going to have a bunch of radicals that don't make a ton of sense. And our approximation would be 0.239 for this function. Or sorry, for this definite integral. We're going to look at one more integral. And in this case, we have an even power of cosine. So we have cosine to the fourth. Or if we wanted to change this up to help us out a tiny bit, we could say that this is cosine squared of x squared dx. This allows us to use the half angle identity that we have 1 plus cosine of 2x divided by 2 quantity squared dx. This will then allow us to FOIL out our piece, and 1/2 squared is 1/4, so I will put a 1/4 out front of our integral. And that gives us 1 plus 2 cosine of 2x plus cosine squared of 2x dx. Again, I guess I'll put a little note that this was the half angle identity. And we'll do that again down here. So with the half angle identity, this will go to 1 plus cosine of now 4x divided by 2. So we have 1/4, the integral of 1 plus 2 cosine 2x plus, and really this is 1/2. 1/2 plus 1 is 3/2, and then we have 1/2 cosine of 4x dx. At this point, we can integrate. We should consider the fact that we do have different u subs within this. If we want to break this up into separate integrals, we may, which might actually be the best solution here. In this case, u is 2x, du is 2 dx. U is 4x, du is 4 dx. Within this, everything kind of balances out. So this actually goes back and you have your du. So we have 1/4 times the quantity of 3/2 x plus sine of 2x plus, and we do need to balance a 1/4. So we will have 1/2 times 1/4, or 1/8 sine of 4x plus c, and we distribute. So that's 3/8 x plus 1/4 sine 2x plus 1 over 32. Sorry, that was bad handwriting, of 4x plus the unknown constant of c that's not affected by distribution of a constant. Hopefully this makes sense. If you have any questions about this, please reach out to me and I will help in any way I can. Last piece before I cut this video will be Wallys Formula. It is used by the textbook. The AP board won't expect you to have this memorized, so don't stress it. But just know this was a way to approximate definite integrals before Leibniz and Newton came around and really refined calculus. So this is just an old school way to evaluate definite integrals for cosine to different powers. The textbook will reference this. I'm not going to stress it because it's not huge on the AP exam, but just know that this does exist. Thank you for taking time to watch this series. Please continue watching as we go into other trig functions and powers. I really appreciate your time. Thank you.